Hello everyone. I hope I'm audible properly. So, as you know, our today's lecture is a guest lecture by Mr. Ronak Shetty, who is a sustainability analyst in Sparta Dharma company, Bangalore. We are going to have a session on sustainability key to the future. Since this is also a part of your syllabus, as you know, and to actually get the gist of what sustainability means and how it is followed in the real world, this session will definitely be helpful for you all. So, few instructions for you all that do not turn your audio or video in between, and whatever queries or doubts you want to ask, we'll have it at the end of the session. Okay, make the session more and more interactive. So, I would request from here on Mr. Ronak to take over the session.
Hi, Pooja. Thank you, Pooja. Hi, my name is Ronak. Uh, I work in a company called Smarter Dharma. So we work in the space of sustainability. We are basically a solutions providing company that work with different clients, offer them solutions that benefit the environment and also benefit them in an economic way. Now, Pooja suggested me to give this lecture as you have a subject called environmental management. Um, I hope I can add some value and you guys have some fun with the presentation here. Um, yeah, so let's start. I'm sorry, I'm connected on two devices. I'll just be logging out of one device right away. Hi, is my voice audible?
Yes, yes.
Yes,
Yes, thank you. All right, so today's topic is the sustainability key to the future. Now, before talking about the future, I thought it'll be important to talk about the past because the past is what got us to the future. So let's rewind back time a little and let's go back way back in time. Uh, Billions of years ago, the Earth looked like this huge ball of gases. Eventually, it started cooling and its temperature started reducing, and it started having its own gravity. Um what happened, according to a lot of scientists, millions of years ago, was there was a meteoroid size of Mars that had once collided with Earth. Now, this meteorite caused a chip from the Earth to come out. This chip that came out from the Earth started rotating around the Earth, and this is now called to be, in today's world, the moon. Eventually, the Earth started looking something like this. This beautiful version of the Earth is what we all are acquainted with. However, for life to exist on Earth, one of the most important parameters or one of the most important factors that comes into picture is the atmosphere. Now, I know all of you guys must have gone into the details of how there are different layers of atmosphere and how they protect us uh, from the outside universe. I'm not going to go much into the details of each of these layers, just brushing through these layers. The ozone layer, the most important layer, which is present in the stratosphere here, that protects us from the harmful ultraviolet rays of the sun. The mesosphere on right above the stratosphere. Um, you see all the meteors burning in that layer. So anytime in the night, if you see meteor shower or stars just moving past, it's a meteor burning in the layer in the atmospheric layer of the Earth. So the atmosphere is one of the most important factor that made life possible on Earth. Now, in the previous slide, you must have remembered that I said that billions of years ago, Earth had collided with a meteoroid the size of Mars. Now, this collision caused the Earth to tilt by a degree. degree is around 23 degrees. So initially the Earth was on 0 degrees. The collision caused the Earth to tilt around in 23 degrees. Now, what this did was it allowed more sunlight to fall along the equator of the Earth than along the poles. So the equator of the Earth started heating up more than the poles. What this did was all the air around the equator became more and more warm. Now, we know as the air becomes warm, it starts to rise. So, the air from the equator started moving towards the poles. Now, in the poles, since there is lesser amount of sunlight, the air gets cooler and falls back down towards the poles. And in this way, the air started circulating from the equator to the from North Pole to the equator, and similarly, and so on to South Pole and each end of the equator. This is what you all must be knowing is called convection. However, there is an important twist here. The Earth is not stationary. The Earth is also spinning. Now, this spin causes the wind that was going to move to the left try to move to the right. The wind that is moving to the right starts moving to the left. Now, this spin of the Earth, uh, uh, along with the spin of the air along the spin of the Earth, is called the Coriolis effect. Now, this Coriolis effect, along with the atmospheric circulation, causes air to be distributed in different parts of the world. In uh, as the air gets circulated along the different parts of the world, each area has its own temperature. Each area has its own climate. So if you are located somewhere near the equator, you might have a much more warm climate, while along the poles, you have a much more colder climate. So just to give you a brief difference between a climate and a weather. A weather is actually a temporary state, a more short-term state of the atmosphere. It's like saying today the weather is rainy, or today the weather is sunny. So it's more of a short-term state of the atmosphere, while the climate is basically weather averaged over years and weeks and months, and that's what decides a climate of a particular area. So this is how the Coriolis effect governs how different parts of the world receives air circulation, and how the temperature of the earth is maintained. Um, the next part, we know about the how the wind is circulated within the earth. A brief introduction about how uh, sun how the earth absorbs solar radiation from the sun. Now, if we look at the earth absorbs it filters out the harmful solar radiations, absorbs most of it, and reflects the rest of it. Now, if the Earth is absorbing solar radiation and reflecting it, how does the Earth continue to remain warm in some areas? How does the night how is the night warmer in some areas? Now, this is because of these gases. All the way from the top, if you see, there's carbon dioxide, there's methane, there's nitrous oxide, there's water vapor. There are many such gases that are present in the Earth's atmosphere. These gases are actually distributed in the different layers of the atmosphere. Now, what these gases do is, so whatever radiations is reflected from the Earth's surface, it's captured by these gases, and this is why we have uh, a warmer temperature around the earth. In the absence of these gases, we just would have been a ball of ice, uh, without uh, without much life left on it. So these are very important gases that are important for our survival and for our existence. This whole phenomenon is called the greenhouse effect. You must have heard about this in school and college. And the gases that help achieve this greenhouse effect are called the greenhouse gases. Uh, uh, one of the most abundant greenhouse gas is primarily carbon dioxide. So um, all the other gases are usually represented as a version of CO2. For example, if methane is 27 times as potent as CO2, so methane is basically 27 CO2. So in this way, greenhouse gases is usually represented as in all the future slides as CO2. So this is how the greenhouse effect maintains the temperature of the Earth, and it has been doing that since millions and millions of years ago. Now, talking about millions and millions of years ago, I have a very interesting graph to share with all of you. Um, and the y-axis is parts per million ppm. I'm sure all you engineering students must be aware about ppm. On the x-axis is years ago. So basically, 600,000 means 600,000 years ago. Now, if you look at this graph, so on the top graph is basically the carbon dioxide levels in ppm, while the bottom is the temperature of the Earth, the global temperature. Now, if you observe this graph from around 600,000 years ago to all the way 100,000 years ago, the CO2 levels in the atmosphere have more or less been along this average of around 200 to 300. Sometimes there's an odd spike that is around in some years. However, all the way until the early 1900s. Now, if you see, the CO2 levels have been on a constant level until it reaches the early 1900 levels. Now, if you see the CO2 levels today, it is around 380 ppm, which is much above than all of this average. So there has been a continuous increase in the CO2 levels after the onset of 1900s. Now, if you see the bottom graph, the temperature also follows the same pattern. Pardon me that we do not have the readings after this, which I'm going to be explaining the next graph. The next graph is more of a temperature graph. It's a much more recent analysis compared to what I shown you in the previous graph. This is from the past 220 years. Now, if you see, the early 1900s is taken as zero. So just from 1900s on 1940s, I think, is taken as zero. Just from 1900s, you see that the CO2 levels have been rising. The temperature also follows a similar pattern and starts rising towards 1 degree mark. This is the y-axis, which is basically in degrees Celsius. Uh, so the temperature has also increased over time after the 1940s and 1950s. Now, you would ask me what happened in the 1940s, 1950s. Um, Nothing surprising. I think most of you guys know what happened. It was the industrial era that started in the 1940s and the 1950s that triggered all of this. So, this increase in temperature to now, that is 1 degree increase in the Earth's global temperature, doesn't seem like a lot for if you look at the temperature on a scale, because when you do some physical activities, your body temperatures also go from 1 degree up and 1 degree down. But this when we are talking about temperature of the Earth, it is the temperature of the Earth. It's on a global scale. Um, uh, the effects of this, whether it is good, bad, I'll be showing you in the next few slides. Now, how do we know all this? So, there are billions and billions of scientists, um, thousands of them, thousands of reports. Thanks to the power of the internet, we can access any papers, any experiments done in different parts of the world, just sitting at our home. And this presentation is a representation of all these reports and claims made by scientists about how the increase in temperature has caused a change in our climate. So let's break it down. Um, Do you think we have a climate emergency? We've seen there's a 1 degree rise in the temperature. Yes or no is for you to decide. What I'll be doing is I'll be presenting to you facts, and based on that, you can decide whether we have a climate emergency or not. Uh, just a second. I'll just take a sip of water. Thank you. Okay. Now we've been hearing a lot of these claims on the internet, on Instagram, on YouTube, sometimes on the news about how different parts of the world, different things are happening. Now, I have put forth certain claims made by different scientists around the world, and we're going to verify it by some facts. The first claim made by one of the scientists are that glaciers are melting. Now, this is a picture of the Muir and the Briggs Glacier. This is a glacier that is in Alaska, in the United States. Now, this is a picture from 1941. You see the picture is a little pixelated, obviously old camera, old pictures. Uh, this is the picture of the same glacier in the year 2004. Surprisingly, you don't see any glacier because all the glaciers are melting. This is a picture of a Peterson Glacier, which initially looked like this, and right now it doesn't even have water; it's grass growing on land. And this is what happened of the Peterson Glacier. It's another glacier in Alaska, in the United States. Um, all these are much far away from home. Let's bring it back a little back to home, to India. Something that we all know. This is the glacier melting stats in the Himalayas. Now, if you see in the Himalayas, this graph represents how much meters of glaciers are lost per year. Now, there's 0 here, zero point 0.5, and 1 meter. Now, if you see from 2000 to 2016, approximately 1 meter uh, of glacier is lost in throughout this period. Now, 1 meter doesn't seem a lot on scale, but if you if you look at the meters of glaciers that's lost and the amount of water that gets increased, it just gets multiplied to 10 times is what we see. So, yeah, there have been analysis conducted and shown that the Himalayas has also lost a lot of glacier over the years. You'll see this particular box with lesser number of blue lines. This is the number of glaciers lost in that particular area. Uh, the next claim made is that the oceans are acidifying. Now, before I get into how the oceans are acidifying, it's important to understand uh, what the oceans do uh, with with CO2. Now, oceans are the biggest sinks of carbon dioxide. They absorb almost 30% of the atmospheric carbon dioxide. Now, what they usually do is there are a lot of anaerobic microorganisms underwater that also survive and thrive on this CO2. However, CO2 is usually broken down in the ocean as follows. It combines with water, forms carbonic acid. The carbonic acid breaks down to form bicarbonates. This bicarbonates gets break down to form carbonates and hydrogen ion. Now, this carbonates is utilized by a very interesting set of species called the coral reef. These coral reefs use this carbonate and they make homes for themselves. Now, and needless to say, the coral reefs are one of the most important ecosystems from underwater. They are a habitat to around 25% of the entire ocean species. Not only that, but they also prevent flooding to happen um, on the coasts nearby. Now, this is something to show some. to show anti-flooding properties within themselves, that they prevent flooding from happening. Apart from that, we all know coral reef has a lot of medicinal benefits. They are food for a lot of organisms underwater. So there's an entire food chain that is linked to the coral reef. However, the increase in CO2 levels in the atmosphere that we just saw in the earlier graph, earlier slides, has caused an increase in the CO2 levels absorption in the ocean. Now, when there is an increase of CO2 absorption in the ocean, the excess CO2 combines with the carbonate and forms bicarbonates. Now, the carbonates are actually used by the coral reefs to make home for themselves. If they are converted into bicarbonates, that becomes a problem. Now, along with the bicarbonate, another byproduct of this whole equation is hydrogen. Now, we all know hydrogen.
Ronak, your voice is breaking.
Uh, is it breaking a lot? Hello,
Hello?
hello. Yeah, can you hear me?
Hello?
Yeah, can you hear me?
Uh, now yes, yes, it's audible now.
Is it breaking a lot throughout the presentation? Hello, hello. Can you hear
No,
me?
no, just for the previous slide it was breaking.
Okay,
Yes,
okay.
yes.
Yeah, yeah, yeah. Um, so yeah, the whole equation of as the CO2 levels above the atmosphere increase, um, like I said, it form bicarbonate. So basically, the coral reef don't have any carbonates to make a home for themselves. Now, the hydrogen ions that is a byproduct of this entire equation, we all know is increases the acidity of the water, which means the pH of the water starts reducing. Now, as the coral reef do not have any carbonates to carbonates to make the home for themselves, and the pH of the ocean starts changing as well, the reef starts bleaching. Now, this bleaching was observed in the Australian Great Barrier Reef, the biggest reefs ecosystem in the world, in 1998, in 2010, and from 2014 to 2017, there's a continuous period of reef bleaching in the Australian Great Barrier Reef. Now, if the reefs, as they begin to bleach, if the pH of the ocean doesn't get back to normal, they die off. And this is how we have been hearing cases about how coral reefs are disappearing from the surface of the earth. Another claim made by a lot of people, not only scientists, is that weather is becoming more extreme. Um, I'll bring you an example that is much more local to all of you guys. We all know this. Every year we experience huge amount of rainfalls in Bombay. However, I'll not go into the details of how the rainfall, but I'm here to show you some interesting stats. Last year, 2020, Mumbai recorded its second highest monthly rain in 10 years. In August, same year, it had the highest rainfall in the last 46 years. So you see uh, how 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 there has been an increase um, in, in the intensity of the floods with time. Um, Other claim made by a scientist is there has been observed desertification and soil erosion. Ask the entire continent of Australia. In the past, in the year 2019, Australia suffered one of their worst drought in the past 1,000 years. The entire continent had no rain at all. Um, Needless to say, this is a once in 1,000 year event and has never been observed in the past recent history too. Now, there is this analysis done by the Millennium Ecosystem Assessment on each continent, and they have measured the number of flooding events that have been occurred in each of these continents. And what they found out was in the past 50 years itself, the number of flooding events just went on increasing and increasing at a much higher rate than it was in all of the years before that. Then one of the main reasons why also flooding is happening in different parts of the world is there are rainforests disappearing from the surface of the earth. We all know uh, every minute forest the size of 20 football fields is usually cut. Now these rainforests are a very important species to control flooding from the rivers. They halt flooding if they are kept in between lands. So needless to say how important they are to absorbing carbon dioxide from the atmosphere too. Another claim made by one of the scientists are that small islands are sinking. Perfect example of this would be on the picture on the left. You'd see an Hawaiian island uh, that once existed on the surface of the earth. Not far ago. It is around 10 years back. However, today that island is not there anymore. It is disappeared. Not only this, nine other countries are at the risk of disappearance due to a change in weather and climate being observed around the world. Uh, One of the most important islands in that you all must be acquainted is the Maldives. Yes, Maldives is also under the threat of disappearance due to climate change. Well, all these stats are fine, but I think now would be a good time to ask uh, whether do you think that there is a climate emergency? Um, the obvious answer, looking at all these facts, I know would term to be yes. But if there is a no, I would like to also get in chat with people. Let's cut to the chase now. Uh, there is a concept called the Earth Overshoot Day. Uh, Now, the Earth Overshoot Day basically measures the amount of ecological resources that we as human species use on the Earth as compared to the ecological species that can be replenished in that same year by the environment. So, for example, if I am using one loaf of bread in Jan, by the end of December, the earth has replenished that loaf of bread. So this is basically a measure of how we are using the ecological resources around us, whether we are using only that much that it can replenish within a year, or whether we are using more. If you see, in August 22, 2020 was our last overshoot day, which means by August 2020, 2020, we have already used the amount of resources, ecological resources that can be replenished. And whatever resources we used after August 22 was something that we used from a future budget. I'd show you another interesting stat here. This is the overshoot date from 1987 all the way to 2020. You'd see the overshoot date just keeps on reducing with each passing year, all the way until August of August of 2022. Now we all know in the year 2020 we had a huge pandemic. Activities that the businesses were closed. There were lesser activities happening, lesser cars on the road, lesser pollution causing components on the ground. You could see the difference in the overshoot day just by 1 year of lockdown on the earth. From July, it's just shifted to literally a month away, which is again August 2022. Not only this, but uh, there's also economic losses that we will be suffering from this whole climate change analysis. A huge analysis by European intelligence unit says that around $7.9 trillion would be required to to mitigate climate change by 2050. Not only this, but adapting to the climate change would cost us another $7 trillion, which means all the flooding events, all the drought events is also costing us money, not only the environmental, the environment around us. Needless to say, it severely impacts the local economies. Uh, the, the poor people are usually the worst affected in all these events. Um, uh, the rich always, get away with the majority of the impact that happens to the world because of climate change. Um, it becomes very hard for these economies to restart because they are from the most underprivileged parts of the society, and the worst affected are these people. Now, there are other factors as well that is happening around the world. One of that is water crisis. This is just a start of India. There's water crisis happening in different parts of the world, which is also getting more and more evident with every passing year. Not denying the reckless use of water that we all do, but there has been an extreme shortage of water, and there's waste. A huge part of the world is suffering with this problem of waste. A very interesting stat here again, I'll be giving you. Out of the 100% of the waste that is generated by the world, 70% is collected. Out of this 70%, only 20% gets treated, and the rest 50% goes to the landfill. So we are also reducing the amount of land that we have left for our future generations as well. Now we are not talking about the 30% here because there is no data available about the 30%. The 30%, what I would like to say is in a country like India, it's most times everywhere around us. It's uncollected, just lying around in clogged in rivers, drains, soil. Um, just just a, a global picture about the sectors that contribute most in terms of greenhouse gases since the industrial era. The highest contribution has been from the energy sector. Now, all the electricity that comes to your home, the generation of that electricity is what is causing the majority of the greenhouse gas emissions. Not one of the major reasons why it is the biggest contributor of greenhouse gas is because majority of the electricity today is made from coal powered plants. Now, coal powered plants are the biggest sources of greenhouse gas emissions. The second highest contributor of greenhouse gas emissions is the agriculture and the forestry sector. There are acres and acres of forest lands cleared for purpose of agriculture. There are millions and billions of cows and buffaloes that are bred in countries like United States, just for food for themselves. These cows, over their life process, release methane, uh, which is 27 times more potent as compared to CO2. So they are the second highest contributors of greenhouse gases. There are again industries, transport from road transport, air transport, rail transport, and there's also a small percentage of buildings contributing to the majority of this greenhouse gas emissions. Now, this is what has happened all over the past, and this is what has led for the world to move away from an approach that is more conventional. Now, if you look at the conventional approach, it is usually money comes first. You first care about the money, then you talk about your neighbors and the societies, but you don't have much problems with that. And the last preference is usually given to the environment. This is the approach that has gotten us so far. What sustainability requires you is to adopt an approach like this. Sustainability puts utmost importance for each of these areas: environment, society, and economy. Now, in any decision making, it is looked from all the three angles. There will be monetary benefit, there will be environmental benefit, and there will be benefits to the society as well. So sustainability involves a more holistic approach towards decision making. I'll be explaining more about this and how it is applicable in the real life, and how I use it in my real life in the next few slides. And now we've been talking about climate change since a long time. It's been years and decades that we've been hearing news. There's been different different people coming up, uh, different popular stars talking about it. But what's really been done on the ground about it? Is there something happening on the ground? Um, are we all doomed? Are we just talking all of this? Is there something happening? Well, thanks to the United Nations. The United Nations is an independent organization. It is a collaboration of, it has members of different countries in them. The United Nations saw the threat of climate change and formed a division called the United Nations Framework Convention on Climate Change. Now, this framework was specifically formed to deal with the effects of climate change. Now, one of the important things that the UNFCCC did was they invited countries from all over the world. And in 1995, they started calling on to have a convention, a meeting, so that they can discuss the problem. However, until 1997, nothing concrete happened. But in 1997, there was something called as the Kyoto Protocol that came. This was a protocol that was aimed to limit and reduce the amount of greenhouse gases that is generated from this whole process. However, this was also not much detailed. It was still over the top. There were no goals given to countries. They were just Kyoto Protocol just allowed the developed countries to help the developing countries, and in return, the developed countries will get some credits. So there was not much progress happening to all of this, and the United Nations were figuring out of how they can change this whole thing all the way until 2015. They had meetings every year, uh, but in 2015 is when they got down to something really concrete. The UNFCCC, the United Nations Framework for Climate Change, decided that we have to limit the Earth's warming to below 1.5 degrees or to the max 2 degrees. Now, the earlier slides I already showed you that the Earth's temperature has increased by 1 degree, 1 degree from 1950s levels. Not happened in thousands and thousands of years, but just happened in the past 50 years. So, acknowledging what we already have, we cannot reduce the temperature further, but we can limit the increase in temperature to 1.5 to 2 degrees. Now, this was a very bold goal set by the United Nations in something called as the Paris Agreement, which was held in 2015 in Paris. Now, this protocol was initially adopted by 195 countries. India wasn't a part of this at that point. However, India did ratify to this particular protocol in 2016, 2017, and this this overarching goal meant the United Nations imposes the onus upon every country to make sure that they reduce their global greenhouse gas emissions so that we can overall reduce the warming to 1.5 degrees or to max 2 degrees. Now, to help achieve this, the United Nations came up with something called the Sustainable Development Goals. Now, each of these goals is solves different problems in the world. It mostly covers almost all uh, global problems in the world, and are goals that are given to every. Hello, can you hear me?
Yes,
Yes,
yes.
yes, sir.
Okay, okay. So these are goals that have been formed by the United Nations. It is given to every country so that they can monitor themselves based on these indexes. Now, if you see, there are social goals here as well, like poverty, hunger, health and well-being, education, gender equality. Very important, reducing inequalities. These are very important social goals. Now, you would be asking me, what are social goals doing here? Well, these are very important goals for the survival of mankind, and they are also they are also interdependent with each other. So every climate action, climate change, climate action that takes place also depends upon social goals. Um, there are also environmental goals set by the United Nations: the clean water and sanitation, affordable and clean energy. There's sustainable cities and communities. There's responsible consumption, production. There's life below water, life on land. So there are such 17 such goals. So that each country, it is made easier for them to achieve. Each of these goals is broken down into different targets, so that every year when the United Nations meet, they can discuss whether the countries have met their targets for each goal. Now, targets could be as simple as converting, for example, let's take the goal affordable and clean energy. A target for affordable and clean energy would be converting 50% of the country's energy generation with solar. That could be a goal. So these goals are laid down by each country to what they will meet, and there are targets specific to each of these goals. Uh, Now, we've been talking about 1.5 and 2 degrees centigrade, so that we prevent the global temperature of the Earth to rise uh, up from 1.5 to 2 degrees. We want it to be between 1.5 to 2 degrees, or 1.5 degrees. But what would happen if this temperature would have to be achieved if in the future? Extreme heat gets 14% worse in a 1.5 degree scenario, 37% worse in 2 degrees. Uh, the number of ice-free summers, which was in a 1.5 degrees, would be once in 100 years. In a 2 degrees, it will be once in 10 years. Sea level rise, which we have already been observing, will be zero point 0.4 meters in 1.5 degree scenario, 0.46 in 2 degree scenario. Multiple species loss. The vertebrates will be lost around 8% in a 2 degree scenario. There'll be plant species lost. There are insect species that have been lost. The amount of the earth land that will shift to a new set of species will also be 7% in a 1.5 degree scenario, and gets almost two times worse in a 2 degree scenario. The Arctic permafrost, basically the ice of the Arctic, that will thaw, which basically means that it will melt. Around 4.8 million kilometers of ice will thaw. Uh, in a 1.5 degree scenario, it gets 38% worse in a 2 degree scenario. Again, crop yields. We already have seen a lot of farmers losing a lot of crops because of uneven rainfall throughout the country that has been happening. Yields, it will get 2.3x worse in 2 degrees centigrade scenario. Coral reefs will almost get extinct if the Earth goes to 2 degree scenario. There's still some chance of survival for these coral reefs in a 1.5 degrees centigrade scenario. Fisheries, one of the biggest problems the fishes have been facing today is survival. They have been 1.5 million tons of fishes would be reduced in a 1.5 degree scenario, and gets 2x worse in 2 degree scenario. So these are the consequences if we even achieve 1.5 degrees centigrade, or to the max 2 degrees centigrade. Now, if we do not achieve that, go beyond 2, the consequences are it just gets more and more worse with time. Uh, Sorry. Yeah. Uh, so is there hope? Uh, Point being, we saw all these statistics and uh, all these figures and uh, all these facts. Do you think we have hope? Well, thanks to the concept of circular economy. There are different concepts that have come out uh, since the past few years, so that this will fast forward our progress to 1.5 degrees and 2 degrees. One of these concepts is the circular economy. The circular economy is a concept that completely like twists the scenario that we have been currently following. Currently, we use a take, make, use, and throw away approach. The circular economy, on the other hand, looks as waste as a resource. So the waste becomes a resource to make a new product, or the product is designed in a way that at the end of the life of the product, it becomes either a new product or it degrades back into the environment. So the principles of circular economy revolve um, around making such products that is circulated back into the world rather than being just thrown away and buried in the underground. Another important concept that is taking a lot of precedence in the recent years is the life cycle assessment. So the life cycle assessment is basically done for a product. So any product from its birth, uh, like from the raw material extraction to the end of life of it, that is after the use of the product and it is thrown away, whatever impacts is happening on the environment is measured. And this impact assessment of the life cycle of the entire product is called the life cycle assessment. Now, there's a very simple example given here. Today, regulations, government, uh, all the government bodies usually focus on the tailpipe emissions that come out from cars uh, and, and vehicles and bikes. Um, Not looking at other things that come in the production chain. The vehicle manufacture, the raw material extraction, the material and components parts manufacture, the end of life disposal and recycling. All of this have have a huge impact and on the environment as compared to what is in the focus by the government is the tailpipe emissions. So there has to be regulations set in all these areas so that so that we can look at it from a very holistic perspective. Which is why I feel electric cars is not sustainable until the electricity used to power that car is produced from a sustainable source. Now, if the electricity is produced from coal-fired plants and all of our fleets become electric, the the greenhouse gas that would increase would be immense, and it would be beyond our comprehension. So, so it is important to look at each stage of the life cycle of a material and a product, so as to come up with technologies uh, and alternatives that would help to reduce the impact on the environment. So the life cycle impact assessment basically looks at each stage of the manufacturing, and you can go dive in deep into each stage and see how you can use an alternative and avoid that impact to the environment. How you can use an alternative process, an alternative technology, an alternative um, a material that can be used uh, as a replacement for making it more sustainable. Uh, this is one of the important concepts that has been taking a lot of precedence in the past few years. Now, there are different certification bodies that help you with getting sustainable. Uh, the ISO, one of the very popular certifying bodies, certifies industry, certifies buildings, certifies hotels, and they make sure that the processes running within the hotel are sustainable and and they are not emitting greenhouse gases beyond what they should. There's the IGBC and the LEED certification. This is for buildings, for the construction sector. Anyone in the construction field can refer to IGBC and LEEDs. These are the certifying bodies that will help you to achieve a building that is much more sustainable. They have certain norms and laws within them that to receive these certifications, they need to fulfill those norms. Then there's a Green Pro certification. The certification is for a product on how it is manufactured, all the chemicals that go into the process, if the product is emitting a lot of pollutants, if there's any harmful emissions coming out of this product, is all checked by the Green Pro certification. There are a lot of companies that follow the GRI certification or GRI reporting structure, in which they report their GHG emissions every year in a GRI format. You must have also been acquainted with of lately. Primarily, the whole what this means is uh, the food is produced in a manner without detrimenting or without causing any negative impacts to the environment. Now, and these certification bodies do have certain norms that help companies to achieve their sustainability goals. Not only this, they also increase the brand image of a company. So if a company is more conscious about the environment, people are more likely to buy their products because they care about a cause much greater than themselves. So all these certifying bodies do the job of doing that, but I would say not to take not to take each company's word of these certifications blindly. We live in a country like India. There are a lot of other social evil certifications also can be bought, but it is important to do your own research about things and about different aspects that happen in terms of sustainability and how different alternatives in sustainability can be adopted so that you can make a difference. So I would like to finish off this today's presentation with giving you something that I do in my everyday life, and it's just a very brief picture of what I do. We do much more detailed work in this, but this is just an overall picture of what we do. Um, let's take, for example, the construction of a building. Um, Now, we know the construction of the building has different impacts at each phases of construction, during the construction, during the operation, and during the demolition. Now, during the construction, there is a lot of deforestation and land degradation. Also, cement, one of the highest emitters of GHG emissions in terms of materials, it contributes to 5% of the global emissions. Uh, is also majorly used in today's world for building buildings. Uh, what could be the alternative? You'd ask me. Well, if, if the trees are removed from particular area to build buildings, the trees, that much amount of trees need to be planted somewhere else, or it needs to be nurtured around the building, and not only planted but taken care of until they grow up. Because there is a very interesting stat about one of the one of about trees that says that all these corporates they plant trees, but there's no one to look after these trees. Around 60 to 70% of these trees even die off before they go to big sized trees. So it's very important to also take care of these trees. From the material perspective, where cement is a huge contribution, what can you do in terms of cement? You can move to a much more materials have the lowest environmental impact. Something like a have much lower environmental impact than cement. And not only that, the uh, the earth-based materials helps you to completely avoid this urban heat island effect. So the urban heat island effect is because of the concrete buildings that is coming up. There is a local heating of the temperature because the material is such that it, it does not regulate temperature but just stores heat. So earth-based materials, on the other hand, they regulate the temperature according to the outside environment. If it is cold outside, it'll be warmer inside. Warm outside, it'll be colder inside. So earth-based construction is a very interesting alternative that you can look at. Also, there are green roofs and cool roof solutions that have come up that you can put on the roof to make sure that the temperature of the building is reduced and is maintained within standards. Now, during the operation phase, we all know we use a lot of water, generate a lot of waste. Um, we also use a lot of energy. Now, considering the stats of that 54% of the water of India is suffering from water stress, we might have to look for our own source of water because we might run out of water. This is why we usually design buildings that have rainwater harvesting incorporated to them. There's a very important study which is done in Rajasthan. Rajasthan, as you all know, has the lowest rainfall in a year in all the states of India. But the rainwater harvesting structures of Rajasthan are so good that they tell, if you want water, please come to us. We'll give you water. They tell all the other states of India that if you want water, come to us. We'll give you water. So it's a perfect example to show that something like a rainwater harvesting done in buildings can really suffice for the water and take care of the water. Not only that, by setting up a composting pit or a biogas plant, you can take care of the waste in your building and generate compost from it, or maybe generate energy from it. This will not only reduce the amount of water bill and waste bill that you pay, but will also give you value. Now, electricity, as I said, 40% of the global emissions around the stat initially which I presented was 34. This is around 40% from a building's perspective. From a building, 40% of the global emissions is for generating electricity. Now, this is a huge cost for every occupant that is occupying the building. The electricity bill, the maintenance bill, the water bill. This is a huge factor for deciding for anyone to deciding to buy a place in a building. Now, now an alternative to that would be to use renewable energy and passive designs so that to maximize the use of lighting and ventilation. First of all, to reduce the amount of energy that the building uses, and then power the remaining energy with renewable energy. Now, this will not only give you clean energy free of cost, but will also put down the amount of maintenance cost that you would have to pay over time and years to come. The last phase is the demolition phase, where the waste is generated from the material. Now, it depends upon what material is used in the building. Now, if it is a cement-based materials, you can recycle some parts of it you cannot. But it is important to use the demolished resources into the fresh construction because they are perfectly usable into the building. And this will not only reduce the cost of procuring fresh materials for you, but will also avoid but also like remove wastes from from the surrounding environment and the world. So this is a perfect example of this. This scenario is the usual case scenario, how the world, if it is allowed to function in normal way, a more sustainable scenario, a more independent building, which is not dependent much on the outside world for energy, not dependent much on the outside world for water, or only dependent on few liters, a few percentage of water, and manages its own waste and recycles the other wastes. So it is important to look at not only buildings. This is a this is an example from the construction sector. In each and every sector that you work today, you can apply principles of sustainability and see what alternatives can give you the best results and what alternatives would have the minimum impact on the environment. There are alternatives available for uh, almost most things today in the world. It's just that it's the lack of ease that we think, oh, this is much more common than it is much easier to do, is what makes us to go with the normal approach. But we have to think above all this and look at it from a whole global perspective. If we have to reduce our temperature, we have to into each and every aspect of our business and of our lives. So yeah, that's it. That's it for today. Thank you. Thank you. Uh, any doubts, you can shoot it out to me.
Yes, students, if you have any doubt, if you want to ask anything, any query, anything related to the topic, you can ask. You're free to ask. You can write it down in the chat section or you can unmute and ask, but do ask.
Any part that you didn't understand, any part that you have a doubt about, anything that uh, anything related to sustainability, you can ask me.
Yes, sir. As you said, sustainability is all about keeping our planet secure as well as going towards progress, right?
Yeah.
So what my doubt was, if it was better to keep everything sustainable, why would the government not think about it? If it is going to progress and if it is going to save our planet, so why not go for a approach which is better as compared to
Well,
the traditional approaches?
yeah, this is a question. It's a very good question. What's your name? That would be
Current, so
Karan. Hi, Karan. This is a very good question. We have been asking the government these questions too. But from our expertise, from our knowledge, what we have observed is the world is used to functioning from years to years in a particular way. And not everyone looks at it from a sustainable perspective. Like I said, in one of the slides, I think must have explained, they first care about money, it's then about society, and then about the environment. However, they have not married these three things with each other to see how they can mutually benefit from all of it. And a lack of approach towards going to such kind of things has is, in my perspective, is what I think has stopped them from going it. Also, there's a general uh, conspiracy thinking about sustainability is very expensive, and people think, oh no, it's very expensive, it's way out of my budget, without even going into the details and analyzing the solutions in details and seeing how it can benefit. They just outright say, no, it's very expensive, I know it. You know, so the approach in a way has good question, Tarun.
thank you, sir.
Yes, anyone else? Anyone else who want to ask any question? Maybe in the chat section or you can unmute and ask.
Funny part is, I just started the presentation without unmuting myself, and I started like two lines of it, and I was like, "Okay, wait, is anyone listening?" It took me a while to realize that I was on mute. So if you're asking any questions, please unmute yourself. Don't be like me.
Yes, please unmute yourself and then ask the questions if you want to ask. No questions then?
No questions?
Huh?
Not anymore, sir.
Ronak, just if you could brief out that how this sustainability and this particular area would be useful for different branches of engineering because we have mixed people here. We have people from
Right,
computers, mechanical,
right, right,
instrumentation,
right.
electronics. Huh.
Yeah, this is a very important, very, very good example of that. Uh, now, if you see, if I want to see sustainability in a vehicle manufacturing plant, my first my first idea would be go talk to a mechanical engineer. Let me see what he has got. So it's there in every field like this. It's not only in mechanical. In mechanical engineering, people talk about more efficient processes, that lesser energy is used. From a factory perspective, like for all the mechanical, electrical engineers who want to work in an industry in factories, it's usually an economic benefit for the factory. So a solution like this would usually benefit them from an economic perspective. Factories are the ones who are much more proactive trying to incorporate these principles. For other fields, like civil engineering, I just showed you an examples of building of how you can incorporate sustainability. IT, for example, or computer science. Um, there are things that you can do in your everyday life that you can contribute, that you can feel that you can contribute to the planet. Even for IT and computers, there's something called as designing softwares that are for sustainable purposes. Right now, what our company is doing is we are coming up with a software that makes a builder that a builder can just go through that software and do certain things and make his building sustainable and see what are the environmental benefits of it, what are the economic benefits of it, how much money he's earning from it. So in every field, like in this particular case, we hired IT and computer engineers just to make the software. So in that way, even it benefits the IT and the computer engineering field as well, the civil engineering field, the mechanical engineering field. There's a lot of research being done into each and every area or branches of engineering, where you can literally look from it from a sustainable perspective and come up with innovative solutions that have never been done before. So, yeah, it is applicable in almost every industry.
Yes. Okay, so students, I hope everything is clear, and I think there is no more doubt from your side. I don't see any questions from your side. So then we will conclude here. So thank you, Ronak, for such an enlightening session. I'm definitely sure that our students would be benefited with this. And thank you for your time today.
I'm glad. I'm glad. I'm
Yes.
glad it helped you guys in any ways. I hope it adds some value to you in any ways. That's it. Thank you for this opportunity. Thank you, Pooja. Thank
Yes,
you,
yes.
college as
Thank
well.
you, sir.
And we are
Thank you.
looking forward to more such sessions with you.
Yes, let's. Yes, even we. I am looking forward to give more success. Yeah.
Okay.
Thank you,
Thank
sir.
you. Thank you, everyone.
All right. Thank you. Thank you.
Bye.
Bye bye.